Good morning.
Morning.
I see you didn't get to putting these snap rings in the plates.
Yeah, I'm more busy. I'll do it after, right?
You know that's not a real sport.
You know building transmissions is like not a real profession.
Okay. No. What are you saying?
Are you filming this?
Yeah.
Let's go build something.
And so another day begins. So what I have here is a pile of junk from a guy's transmission that I'm going to rebuild today. And I thought this would be a really good time to talk about upgrades. It was given to me all in parts. I'm pulling out what I think is important to show you guys a few things about this particular transmission. Okay, you see I got a bunch of parts here. This is from a 1965 M20 Muncie 4-speed. It's out of a 1965 Corvette, and it's a matching numbers transmission, meaning that the VIN number and production dates of the transmission match the VIN number of the car, and the little protector plate that they used to give on some of these GM cars. The serial number of the transmission matches the protector plate. Very important if you're doing restorations for Corvettes. Anyway, something that happens often, I wanted to just tell you this. People come into me and they say, hey, can you just put new bearings in my transmission or put new synchronizer rings and just reseal it and send it on its way? Yet the guy's probably got $10,000 into the engine. And so my reply is always this, is that you're not going to change 6 of the 8 pistons. You're not going to just change your rod bearings and not do your main bearings. And you're not going to leave your old piston rings on the new pistons. So when you rebuild an engine, you pretty much go through the whole thing. And it's kind of weird because when we're used to doing upgrades, people will upgrade their brakes and put better brakes and better master cylinders in it. They'll put better carburetors on the car. They'll even put a nicer shifter on it and even a better stereo. But when it comes to transmissions, and I think probably it's because you don't see the thing, because it's buried underneath the car, you figure I'll just put in whatever I need to get it done and get it out of the way because I'm not going to look at it. But when I do gearboxes, I put everything new inside of them. I take the old gears and I give them back to the customer and I say, do what you want, sell them on eBay, put them on a shelf, use them as paperweights, I don't care. And the reason is because I can't determine how long a gear set is going to last when it's 53 years old. So if the gear set is hammered, it's been overheated or whatever, it's not in his best interest and my best interest to just change one gear and change one bearing. And so in this particular transmission, I'm going to show you the little things that I find in the unit and how I upgrade it and what I do. So if I briefly look over this basket case of parts, you know, some pieces aren't that bad, but in general, we've got this front bearing with the max capacity and the cage is running against the inner ring. This is a common problem with these bearings. The engagement teeth on the input shaft are not too good. Counter gear is pretty good shape. But now the problem is, do we put new gears against 53-year-old used gears? I don't like doing that. So once one gear is bad, I change all the gears. This particular bushing came out from the inside. It spun in the case. The yoke is all scored up. So I'm going to have to put another extension housing on this. And this housing, anyway, was the wrong housing. And it's got some silicone sealer on it. So obviously it was rebuilt before, gone through, and somebody changed this extension housing for one reason or another, I don't know. The speedometer gear is all banged up. It's got all the chisel marks typical of somebody not knowing how to take a speedometer gear off correctly. It's in one of my videos how to do this, by the way. And the rubber mount, look at that rubber mount there. It was just corroded. Look how bad and dried out and rotted it is. I also wanted to touch upon the main case, which is very critical. If the main case isn't set up right, well then all that good work in putting in new gears is going to be meaningless. So this particular transmission had a main case with a countershaft bore of 7/8 of an inch. And so what typically happens is that the countershaft bore wears and elongates over a period of time, stretches out, and oil leaks past the countershaft and out of the transmission. So you might see a lot of cases where they might have peened the ends of it to kind of close the aluminum up a bit so it stops leaking. And that's really not the right thing to do, because the shafts, the upper and lower shafts, are not running parallel anymore. The front shaft is kind of running down relative to the upper shaft, which is running straight. So it's very important that you, if you get a case that's leaking, that you bush it properly in the front and the back. In this particular transmission, because it had a 7/8 inch countershaft, which they stopped doing in 1966, I just had the case bored out to fit a 1-inch countershaft and realigned so both the upper and lower gear trains are running perfectly centered. It's very important to do. This particular job, I'll be installing a brand new M20 gear set for the 1-inch countershaft. This is an Italian gear set along with some Zero Rock synchronizer assemblies. This should really come out to be a really nice shifting transmission. New first gear, second gear, third gear, input shaft, counter gear, forward, reverse, either, and Zero Rock synchronizer assemblies matched for 1, 2, and for the 3, 4. Well, let's look at the mid plates. I don't know what happened to this particular mid plate, but it's got a lot of metal and it kind of got deformed and smashed in, and the snap ring groove looks okay. Sometimes a lot of mid plates, you'll have a lot of movement this way in the snap ring groove. Even some of the so-called upgraded mid plates, there'll be a lot of movement within the snap ring groove, which defeats the purpose of having a well-designed mid plate. Another thing about this mid plate, if you look right in this area over here, you could see where the countershaft has been digging into it. In other words, it's trying to spin and turn, and it keeps on working at the plate till eventually I've seen them cut the whole thing away, and then the shaft starts spinning, it starts spinning in the case, and that's how your case gets ruined. This little edge of the shaft here is starting to work its way in, right here. It's starting to work its way in and work back and forth. So the new design, where you have the shaft actually bolted to the plate, prevents that from happening. So the billet mid plate I manufacture, number one, has a nice tight tolerance for the snap ring. It doesn't walk around in the groove. Check out some of the plates that you may have and check to see how the snap ring fits here. See if it actually moves in the groove much. It really shouldn't. It should have about 1/1000th clearance for the ring actually to get into the groove. So what I do is I upgrade all the transmissions I build with a mid plate. It's billet. These are very accurate plates. They're within 1/1000th thickness all the way around. It's got a little hole over here that the extended fit countershaft bolts to, so it can never spin and walk around and walk out of the transmission. So the extended fit countershaft will be physically attached to the plate, like so. This particular main shaft was in really good shape. There was nothing wrong with it. It cleaned up very nicely. So I am going to put a new reverse gears set in this transmission because for the most part they were pretty well hammered and it needs to be changed. So another upgrade often overlooked is the first gear sleeve. This is a stock sleeve. It's in actually pretty good shape. This is the one that came out of this transmission originally. Let's notice something. It's got a little bit of a valley in it to collect the oil. It's also got a very square edge to it. The reason why they have the square edge is so it makes maximum contact on the rear bearing and the 1-2 hub. Now, I've seen floating around on the internet these upgraded sleeves with the oil slots, which are a really good idea, but they kind of have this really nasty chamfer to the end of them, okay? And that chamfer, the problem is a lot of the new bearings that you get have a chamfer built into it. So when you put these two pieces together, you're on a very thin edge actually against this bearing. Now, this particular piece happened to be with this bearing in a transmission that I took apart for somebody. I don't know if you could see it, but there's a very shiny edge right over here. It's about 15/1000ths, and that's all this first gear sleeve with the taper was making contact with. Now, the factory bearings had a square edge, and you could do that. The problem is the square edge bearings are no longer available. So you have to be very careful because if you're using this particular type of sleeve with the chamfer, you can actually push this thing in over the chamfer and it can go in too far and lock your first gear up. So make sure that at least it's making contact, that this chamfer is not going through this chamfer. So what I did was I come up with this where we've got the grooves cut into it, but we've also, see, we don't have a valley here for the oil. So now I've got a valley and a square edge. So I don't have to worry if I'm selling a sleeve to somebody, depending on what bearing they use, it's going to work, it's going to mate with it properly, and we're not going to have any problems down the line. Another upgrade is these shifter shafts. These are 64-65 shifter shafts with the 5/16 thread, okay? And then somebody had put a later shifter shaft with a 3/8 fine thread in the back for reverse. Now the problem with Muncie 4-speeds is that these tend to leak a lot because for some reason GM decided to make these shifter shafts undersized. The seal requirement, in other words, this is the typical seal, it's a 7410 Chicago rawhide seal. The spec on this seal is for a .750 shaft, 3/4 inch shaft. These particular shifter shafts, they end up being around 745 thousandths, 5 thousandths under. And a lot of times if they're worn a little bit and the cover's worn a little bit, you're going to get leakage. So what I do is I replace those with these billet shifter shafts that are TIG welded at the end, so they're nice billet. We eliminate the studs and we use a regular 5/16 fine hardened steel grade 8 bolt that goes in here. Like this. And these bolts obviously don't break as much as studs break. So it's a great upgrade. And you can see now that this thing is 750 thousandths, all right? So what I do is I actually take a two-step process with these reamers. This is a 750 thousandths reamer. This is a 751 thousandths reamer. So I ream the bore to 750, then a final ream at 751. I do it in both the cover and the extension housing. And I've reamed these both out to 751 thousandths, giving me 1 thousandths clearance with the billet shifter shaft. So I got a nice tight fit in the bore. It's not going to wobble around. I've restored the fit of the bore. And now when I use the seal is going to have a lot more tension on this shaft than the old system did. So we'll eliminate leaks. While I'm at it and I'm talking about covers, you've probably seen this before on the internet, is the pivot pin for the covers on the early units was just pressed in without a hat, pressed in from the inside like this. Here I am, I can almost push this in by hand. These would have a tendency to fall out and have the interlocks just drop into the case. The new pivot pins that they use, I took this off another cover, have a little bit of a hat on it. I'm actually trying to make these now because a lot of people are asking for these. So you put the pin in from the outside now. I use some, locking compound on this as well so it doesn't leak through here. And at least it can't fall in the case anymore. That resolves that problem. If you're desperate, you could simply weld a washer to the end of it if you want and put it back in this way. The other thing is the springs. Typical cover has this spring on it. You can see that it's got these long ends. I replaced the spring with what they call the standard 20-pound spring. It's a little bit more tension, keeps it from hopping out of gear, and gives you a little bit more defined shift. So this cover upgrade, we're going to have the billet shifter shafts, the new hat pin, and the springs. When building a Muncie 4-speed, always inspect the forward edge of the reverse idler, the front idler. And if you notice on this one, you could see these distinct little areas that were actually hitting the 1-2 slider. This typically happens when you put it in first gear. There's somewhere on the shift fork. Slider gets sucked in too far, especially if you're using these torque locking sliders, which I don't recommend. It'll pull it in and it'll bounce against this idler and create noise in first gear, a chirping noise. Now, the new reverse idlers, the Italian ones, are cut back more. They have more of a relief on them. You see that right over here? And that prevents that from happening. You can easily put these on a surface grinder if you want, or a grinder, and cut the edge and clean it up and do the way this one is. It's cut back this little bit so you don't have that problem ever again. So if you're rebuilding the transmissions, I always take these and trim them back a little bit on a bench grinder. Or if I'm putting a new gear set like this one, I'm going to put a whole new gear set in. I'll use the upgraded idler as well that already has the chamfer cut into it to clear the one to sleeve better. This unit was leaking from the front, and you can see that it's really worn over here. For I don't know what reason it is, but the nuts get loose on these sometimes, and they walk forward and they walk into the front bearing retainer and cause excessive clearance. So this is just going to get a new retainer. This isn't an upgrade, but just wanted to show you that when you're building a unit, always check the front bearing retainer. If it's got any type of wear on it, you're going to get leaks, so you want to change it. You should never reuse the nut. Now, since I'm replacing this gear set, I just want to talk about some of the Italian gears versus the Taiwanese gears. I find the quality of these gears very comparable in the sense of the machine work. And at times, actually, I'm going to admit that some of the Taiwanese gears, this is a Taiwanese gear, this is an M22 Taiwanese input shaft, the quality of the machine work is really good. The problem with the Taiwanese gears is the engagement teeth. What they're doing is they're putting a back cut on the engagement teeth. So all the gears that you see on eBay or on the internet that people are selling, quite cheaply I might add, have these back cut engagement teeth compared to the Italian gears, which are more to print. They're more to what the original GM gears had. The problem with these torque locking engagement teeth, although it may sound like a great idea, is that if you use a slider with a straight spline, it's only going to engage the tooth at the very point and will actually have a tendency to fall out of gear. So if you're using these particular types of gears, you must use locking sliders with them. Do not use standard sliders because they will fall out of gear. So you must use a locking slider with these gears. You can use a locking slider with these gears, but it's not necessary. If you use the Zero Rock matched sliders and hubs, there's no reason to do that. You promote less fork wear, and you get a nicer shifting transmission. So I think it's about time I talk about shimming input shafts. Input shafts in Muncie 4-speeds, a lot of times people put shims over here in between the input shaft and the front bearing because they read somewhere that's cool to do and that it moves the input shaft in more and takes up slop in the synchronizer rings. Now, you should never move input shafts into a different position that have been riding against the same gear for 30 or 40 years. You're asking for trouble doing that because you're going to change the contact pattern of the gear set and you may have gear noise after you're done doing that. So I never recommend adding more shims to a used gear and because you thought that that was cool to do and somebody gave you some great idea on the internet. And what usually ends up happening is you'll prematurely wear out the input shaft, probably break it, and then cause gear noise. But with new gears, the question is to shim or not to shim. Now, these new Italian gears that I have, they already have the comb moved in about 20 thousandths to compensate for some of the slop that was in factory gears. And inside the input shaft, it's very important because this particular area over here, you can actually weld up against the tip of the main shaft if you push the input shaft in too far. So if you take a little time to kind of measure things before you put the unit together, you can actually see how much you can push it in before you're going to have a problem with the unit locking up and destroying the input and the main shaft. Let me show you how I do that. So here I have this whole gear train assembled with the upgraded billet mid plate and the Italian gear set in here, the Zero Rock synchronizer assemblies. It's all good to go. And we're going to get this into the case of the transmission. But we may want to shim it, okay? The first thing you do is, without the synchronizer ring, simply put the gear against this. Now, what's going to happen is this is going to touch in the inside with this, whereas this point here is going to contact inside of here like that. A lot of times when people do this, it actually welds the two together. So you can take a caliper and measure, just as a reference point, let's just go here. The slide is pushed back this way, without the ring in place. We can kind of eye things up. And you've got roughly about 140 thousandths, okay? This is your spot where it's going to start to weld. Now, if I put a ring in here, now keep in mind that the slot that you see with synchronizer rings, a lot of people will see the ring flopping around, and they don't realize that this ring is jacked up all against third gear and needs clearance. So the rings need clearance for them so they don't lock up. Now if we put this ring on here, and now we put the input on this way, and we lock it against it, this is another problem. You could shim in too much and actually jack the fourth gear ring up against the input shaft like this, and lock the whole unit up. Now remember that last measurement, And now you've got, let's see, about 160. So you got the difference between the two. It's not that much, okay? Think about that. 30 thousandths difference between no shim against it, locking the input up. Now what happens is sometimes you could have a worn ring that's sitting flat against the gear. Somebody doesn't want to change it, and the unit will lock up. So now we know this is our position. So our safety zone is if we want to lock this unit up, this thing has to be about, let's just say 170 thousandths, 175 thousandths. Ideally, you probably want it somewhere around here. So you want to have slop. You want to have some play here. You don't want them to be tight like this. You want to have some play where the rings can move around a little bit so it's got movement and it doesn't burn itself up. So what I have here is a 385 1325 case. This is a 6465 casting. This is actually from a 1965 Corvette. The VIN number on this over here is from the S plant, which is St. Louis. So it is a 65 case. I have these cases redone. The ears are spot faced. They're drilled for drain plugs and they're retapped correctly to fit new fill and drain plugs on them. Magnetic plugs, I might add. The case is bored out for the larger counter shaft. In other words, this is the old 7/8" counter shaft, you see? And now it's fitted for the extended fit counter shaft. Perfect. So when I put this together now, we'll be able to use the later gear set in the old style case, maintain the guy's serial numbers and matching numbers for his case, side cover and tail with no problem. You're going to have a nice looking unit when it's together. So because I'm upgrading this gear set to a newer style gear set, just wanted to point out a nice important feature, and I've shown this before in some of my other videos. The old gear sets are straight through as far as the machining goes. The counter gear, it's got a nice clean bore that you could see over here. And that utilizes a spacer tube for the needle bearings. And a lot of times when you put these units together, you have to kind of grease the tube, hold it in place. Hopefully it won't drop down. So you put the tube in, the spacers and the needles, and it can be quite a mess. The new counter gears have a spacer tube, so to speak, built right into it. The wall is machined thicker to compensate, so you don't need to have a spacer. It does two things. It obviously makes it very easy for you to install needle bearings now, and it also gives you a stronger wall. So the gear itself becomes stronger because it's thicker over here. So I like using these new gears that have the spacer built into it. Number one, again, it's a stronger piece and makes life a lot easier when it comes to assembling the needles. I just want to show you a comparison of the early M20 input shaft versus the later M20 input shaft. Again, this has got 24 teeth, this has got 21 teeth, and you could see, if you can line the teeth up, how thick the later one on the left here compared to the one on the right, the teeth are. So it's a bigger tooth profile, thus it's a stronger gear. Gives you the same overall ratio. This was like 256, this is 252. Pretty close, but you get an idea. While we're at it, people are always asking me about slingers and how they go on. The protruding inner edge always faces out like this. Very simple. That's how it goes. And the reason is because it's going to act as a bearing shield. Very simply, it's going to go on like this. It's got to have space. If we put it this way, it's going to be up against the bearing and it's going to get squashed against the bearing. So always remember, this protruding edge faces the back side of the bearing or faces towards the front of the transmission. You've got these other slingers too. I don't really like these ones with these tangs, and also the metal's very soft. It's very pliable and bends. It's not like these slingers have a little bit more sturdiness. They're a little bit harder. So I'm not a fan of these little rinky-dink slingers that people are selling. So this one goes on like this. Fits good. Bearing goes on, snap ring facing forward, like this. That's how it goes. Very simple. Now, we can always take this off and that's what we're going to do. We're going to put the slinger in here. We're going to see how this feels with the slinger when it's in the case. If it's too tight, I'll remove the slinger. I don't think I'm going to have to though. All right, so I finished reaming out the extension housing, and I also chase all the bolt holes for the shifter mounting, chase all the threads, make sure the threads are in really good shape. One important thing is that I drill the hole over here for the mid-plate dowel pin. I drill that hole in both the case and the extension housing to 5/16 because the new mid-plates use a standard 5/16 dowel. That's very important. So before you assemble the transmission, if you're going to use one of those plates, there's usually instructions with them. Make sure you open up that hole to 5/16 because you can crack the extension housing or even crack the main case. But these threads here look really good, and everything looks really nice in this extension housing, so this is going to be a really nice build. But you can see over here, this is the new shifter shaft that's in here. The holes have been reamed. It's all ready to go. Well, two-part epoxy. You can get it at Home Depot, other hardware stores. It gives a gray light thick consistency. I always tend to put it right about over here because some of these tapered pinholes on the reverse are kind of spread out a bit, and it's pretty much color-wise. It blends in a little bit with the aluminum. You don't really see it that much, but it adds a little extra protection against the leaking over here, especially if the holes have been elongated from people banging on them. So mix a little bit up over here, put it in over here, let it sit overnight, and at least we won't have any leaks coming out of that tapered pin for reverse. So I also got the front bearing in over here with the nut. Everything's in place. Gear train looks really good. Lines up very well, as you can see. And also, what you want to do is you want to put the transmission in reverse, and you want to hold it over here and spin the back side with a yoke in the back. And if it spins pretty much like this, nice and easy, you know you really don't need to worry about maybe removing that slinger. Spins nice and easy. Doesn't have any bad amount of drag on it. Feels really good. So we can leave the slinger in here, and we've got good alignment with the gears. And we can finish buttoning it up, put the front bearing retainer on there, and the side cover. Now what I'm also going to do is put a Hurst shifter on this because that's a good upgrade. The factory shifter that the guy gave me was destroyed. It was in really bad shape. Didn't want to use it. And you can buy these sticks that look like the Corvette factory sticks. You can get them from Eckler's or Corvette Central, you know, one of the Corvette suppliers. Bolted on so you've got the little pull-up so it looks like the factory stick. But it's always good to have positive stops, and that's what the Hurst shifter has. So I like using positive stops because I don't want to stretch out the cover mechanism. I've got a new fitting kit for the speedometer and a new speedometer gear. He had a 21 tooth red gear in his old transmission, so I'm replacing it with a new gear and a new speedometer fitting kit. Most of these speedometer fittings are pretty rusted. Some of them don't have seals in them. This one comes with a new seal. It's ready to go. But what I want to show you is that a lot of these extension housings, especially the old ones, when you put these things in here, they fit really loose. This is something that was a problem with these, and they kind of work themselves loose, and the O-ring seal starts to go bad and they leak. So what I like to do is put a little anaerobic gel around the fitting and, you know, grease the gear. And when this thing sets up, it's going to give it a nice solid seal. So because these things are loose, this kind of helps it. And that's another little trick I do. These particular tail housings I don't like with the speedometer gear on the driver's side. It gets away in a lot of the shift linkage applications, but when you're doing a restoration, casting numbers are very important, and this particular unit requires this casting number associated with a speedometer being on the driver's side. So unfortunately we have to use this, otherwise it really wouldn't be my choice. I would prefer a speedometer fitting on the passenger side away from the shift linkage. My transmission's all together, all the upgrades are in it. This came out super nice. Now a lot of people may argue that I'm not using the original hardware. The original hardware on this transmission was absolutely horrible. It was rusted, stripped out, and wasn't matching anyway. So I put all new hardware in this transmission. I feel a lot safer that the bolts aren't going to break, and they just look better. I also installed obviously a new Hurst shifter. I have this particular linkage set up in another video online if you want to see how it's done. I use my hardened steel bushings in this particular setup again. I always use these bushings because if you look at the rods, they don't move. I'm trying to twist these rods, and with these bushings and the clips I use, the rods don't move around at all. It does two things. Gives you a good positive shifting transmission and prevents the rods from actually rattling around. They're nice and tight, they're not going to rattle and vibrate. Now this guy's got a Corvette, so I'm putting in a new yoke in it. It's a new forged steel yoke, goes in the back over here. I also always leave the alignment key in the shifter when I ship them out. Keeps everything from moving around, and at least the person has the key there and knows that it's in neutral, it's locked, so nobody can shift it while it's being shipped or something. This guy's just picking up this unit. Since the bearing retainer was bad, I obviously installed a new bearing retainer. This is my retainer kit. Comes with new lock plates, 4 bolts, brand new retainer. And if you can see down here, the case was again bored out to a 1-inch countershaft. It's got the extended fit countershaft that comes almost right to the end of the case. So here we have it, a nice looking transmission, ready to slam some gears. So thanks for watching this video. You know, if you haven't subscribed to my YouTube channel, it would mean a lot to me if you did. And also hit that like button or dislike button, and please leave some comments below. I do pretty much answer my comments on a daily basis. Sometimes I'm away, sometimes I can't get to them, but I will answer all your comments and all your emails. Also, if you would like, I do have a book on Muncie 4-speeds that's available on Amazon.com, as well as directly on my website. The links are below. Thanks so much for watching. See you soon.